I'm Randy Merritt. I'm a geology professor here at the University of Texas. The research that I do is called structural geology, but what that actually means is that I study the deformation of rocks. Of course, you can't squeeze a rock in your hands very much, but the earth can squeeze rocks a lot. The manifestations of that deformation, in terms of things that you can see without a microscope or any special tools, primarily take the form of folds, where various features inside of the rock get deflected so that they make roughly wave kind of shapes. But then rocks can also break so that various types of fractures form inside of the rock. Probably one of the more familiar versions of that is a fault, where earthquakes take place. Earthquakes are one of the more dramatic versions of deformation of rock. And what's happening in that case is that the fault itself divides the earth into roughly halves, and the rock on one side of the fault suddenly moves relative to the rock on the opposite side of the fault. And it moves so suddenly that things analogous to sound waves go propagating out into the surrounding rock, and human beings sense shaking associated with earthquakes. The locations where I do most of my research are in mountains. So I do a lot of work in the Andes in South America, do a lot of work in the Sierra Madre Oriental in northeastern Mexico, and in various locations of the Rocky Mountains in the United States. From a geological point of view, one of the advantages of working in mountains, of course, is that lots of rocks are exposed there. If we were there a couple million years ago, we would find that the locations where you can now walk around would have been hundreds of meters or even kilometers underground. So in a sense, we're literally walking around inside of the earth. When we're out there looking at the rocks, the kinds of things that we're paying attention to be able to make observations that are pertinent to the deformation of them, are the orientations of various features inside of the rock, such as fault orientation, or the orientation of layers that have been folded. And for those sorts of observations, we use a compass. Another fundamental thing is where the structure is, so that when I'm walking around doing field work, almost invariably in one of my hands I've got a notebook that has maps showing the topography of the earth or aerial photographs of the earth, and I partly use those just to navigate as I'm walking around in the field, but then in addition to that, I use them as the base on which to record my observations. Well, ultimately, the goal of geology is to understand how the earth works. And innumerable processes are taking place, some of which people are aware of. Every time a landslide occurs, or a flood, or a volcanic eruption, that's essentially the earth in the process of living its own life. So the goal of geology is to understand how those processes work and how we can avoid the hazards that they impose upon us, how we can affect various parts of the planet ourselves and learn to mitigate the effects that we have on our own environment.